So let us cover some examples. So consider two balls. So both these balls have charge q and they are repelling each other and they are in equilibrium. So we need to write down the equilibrium equations. So the weight acting down is mg, where m is the mass of the body, and we have the repulsive force in opposite direction. So this is body is in equilibrium. So say there is tension T in the strings which is attached to these two balls, and the string makes an angle theta with the horizontal. The distance between the balls is given to us as r. So what are the equilibrium conditions? So these two balls are repelling each other and are just sitting there stationary. So say equilibrium at point A, that is on the left side. So you have the force is equal to, given to us as T cos theta, the magnitude of the force, and weight mg will be equal to T sin theta. Now you divide T sin theta by T cos theta, you get mg over magnitude of the force is equal to tan theta. But this force is given to us as k q square by r square. So we are only worried about the magnitude. And if you plug this in, you get the angle theta, or you get the conditions for the equilibrium. So tan theta is equal to mg r square divided by kq square. Now another example, say you have a triangle and you have three charges placed at the corners of the triangle, and this is an equilateral triangle. Each side has length r. So the magnitude of the force between all three charges, pick any two, the magnitude will be kq square by r square. So because we are dropping the negative sign if there is any, because we are taking the absolute value. So what is the force acting at point A? So let us draw the forces. So first notice that the force will be in this direction, yeah, because q and minus q are opposite in sign. So charge at point B is actually exerting force or pulling the charge at point A. So this force which I have drawn in green has two components, F cos theta and F sin theta. So at point A you have two components, a horizontal component which is F cos theta and a vertical component which is F sin theta. And then we have a force which I have just drawn in purple, which is exerted by the charge at point C. So charge at point C is the same sign as charge at point A, so it is repelling it. So you have a force which is, we are calling FAC vector, that is force acting on A because of charge at C, FAC vector. This is in the negative x-axis direction. So now things are clear at point A. Force AB vector, this has two components, F cos theta I vector plus F sin theta J vector. And this we can write more succinctly as F cos theta F sin theta within the angular brackets. On the other hand, FAC vector, it is just has the component in the x-axis, and that too its magnitude is minus f. So you have f times minus I vector, because the direction is minus I vector and there is nothing in the vertical component, so you get minus f comma 0 as the FAC vector. So for net force at A, you just add the two vectors by the principle of superposition, FAB vector plus FAC vector, and this is nothing but f cos theta minus f comma f sin theta plus 0. So you get f sin theta. So now we talk about net force acting at point B. So you have force by A on point B, which is acting towards point A because they are in opposite in charge. And again, you can decompose this force into horizontal and vertical components. So say you have an angle phi here. So this would be f times cos phi, because all three vectors have the same magnitude of force, and you have f sin phi in the horizontal direction. And you have also FBC vector, which is pointing towards charge C. So again, you decompose it into vertical component, which is f cos phi. Here you can see the adjacent side is always cos and the other side is sine. So now let us write down the net force at point B. So you have f BA vector. Both the components are negative. Yeah, the f sin phi is the component in the negative x-axis. So you have minus f sin phi, and the vertical component is minus f cos phi. So you have minus f cos phi times j vector. So you write it more succinctly as minus f sin phi comma minus f cos phi in angular brackets. And then you have FBC vector. So again, in the horizontal axis it is positive f sin phi, but in the vertical axis it is pointing towards the negative y-axis, so we put it as minus f cos phi j vector. So you write it as angular bracket f sin phi comma minus f cos phi. So the net force by the principle of superposition would be FBA vector plus FBC vector. So you add these two. So you get 0 minus f sin phi plus f sin phi, and you get minus 2f cos phi for the vertical axis. So for an equilateral triangle, you can put theta as 60 and phi as 30 degrees and just put it in and recompute.